A beautiful and blissful morning to all my dear students. Students, as you all know, we are about to begin our first unit test, right? And you must have received your portion paper and also the exam date for your first unit test. So, children, let's start with our revision and get prepared for our exam so that we can score a good grade, right? Today we will be starting with revision number 1 from Science 1. So, children, let's begin. Question number 1. Complete the sentences and explain them. First, the minimum distance between the start and finish points of the motion of an object is called the dash of the object. So, what would be the answer, children? Displacement. Yes, the shortest distance between the initial and final position of an object is called as displacement. Second, deceleration is dash acceleration. So what we can say here? When a body is decelerating, it means its speed is decreasing, right? So an acceleration with a negative also shows that the speed of the body is decreasing. Therefore, here the answer is negative. Next, when an object is in uniform circular motion, its dash changes at every point. So, answer is velocity. And what is the explanation for it? In a uniform circular motion, the direction of motion of the body changes at every instant of time. This continuous change in the direction of motion of the body at every instant accounts for the change in its velocity at every point of instant. Understood, children? Next, during collision, dash remains constant. So, what remains constant? The momentum of the system. When two bodies collide with each other, action and reaction force comes into action. That is, two bodies exerts force on each other. Next, the working of a rocket depends on Newton's dash law of motion. Answer: the burning fuel inside the rocket creates a forward push on the rocket. This forward push creates an equal and opposite push on the exhaust gases. Thus, the working of a rocket depends on Newton's third law of motion. Understood, everyone, children? Let us begin with question number 2. Choose one or more correct alternatives. You have to choose one or more than one correct alternatives for the following. First one. For work to be performed, energy must be dash. Options are: first, transferred from one place to another; second, concentrated; third, transformed from one type to another; fourth, destroyed. So the correct answer is transferred from one place to another. Second, joule is the unit of. force, work, power, energy. So the correct answer is work and energy. Joule is the unit of work and energy. Third one. Which of the forces involved in dragging a heavy object on a smooth horizontal surface have the same magnitude? Options are the horizontal applied force, gravitational force, reaction force in vertical direction, force of friction. Here the correct answers are gravitational force and reaction force in vertical direction. Fourth one. Power is a measure of dash. Options are the rapidity with which work is done, amount of energy required to perform the work. Third, the slowness with which work is performed. Fourth, length of time. So, what is power, children? Yes, the rapidity with which work is done. Correct. Next one. While dragging or lifting an object, negative work is done by. Options are the applied force, second, gravitational force, third, frictional force, fourth, reaction force. Answers are gravitational force and frictional force. Got it, children? Let's move to the next question now. Rewrite the following sentences using proper alternative. First one. The potential energy of your body is least when you are first, sitting on a chair, second, sitting on the ground, third, sleeping on the ground, fourth, standing on the ground. So what can you say? When is the potential energy least? Correct. It is sleeping on the ground. Next, the total energy of an object falling freely towards the ground dash. Options are first, decreases, second, remains unchanged, third, increases, fourth, increases in the beginning and then decreases. Absolutely correct, children. The answer is remains unchanged. Next, if we increase the velocity of a car moving on a flat surface to 4 times its original speed, its potential energy dash. Options are will be twice its original energy, will not change, will be 4 times its original energy, or will be 16 times its original energy. The answer is will not change. Fourth one, the work done on an object does not depend on dash. Options are first, displacement, second, applied force, third, initial velocity of the object, fourth, the angle between force and displacement. The correct answer is initial velocity of the object. Let us now see question number 4. Study the following activity and answer the questions. So here is an activity given. After reading this, we need to answer some question. So let's begin. Take two aluminium channels of different length. Place the lower ends of the channels on the floor and hold their upper ends at the same height. Now, take two balls of the same size and weight and release them from the top end of the channels. They will roll down and cover the same distance. Understood the activity? Now let's answer these questions. First one. At the moment of releasing the balls, which energy do the balls have? Answer. At the moment of releasing the balls, they possess potential energy. Isn't it, children? Yes. Second question. As the ball rolls down, which energy is converted into which other form of energy? Correct. The potential energy of the balls converts to kinetic energy as they roll down. Third question. Why do the balls cover the same distance after rolling down? Answer. The balls will possess same potential energy because the channels are of same height as well as the weight of the balls are same. Thus, both the balls cover equal distance after rolling down the incline because they possess same potential energy at the top of the channels. Got it? Fourth one. What is the form of the eventual total energy of the balls? Answer. The total energy of the ball will eventually be in the form of kinetic energy. Fifth one. Which law related to energy does the above activity demonstrate? Explain. Answer. Law of conservation of energy is demonstrated using this activity. At the top of the channels, the total mechanical energy of the ball is in the form of potential energy. Now, as the ball rolls down, they come into motion and possess kinetic energy. Also, when the ball reaches the bottom, the total mechanical energy of the balls is in the form of kinetic energy. This shows that all the potential energy of the balls got converted to kinetic energy at the bottom. Understood, children? I hope every one of you have understood. So, children, all the best for your exam. Please write the revision in your book and learn them. It will help you to score good in your exam. Once again, I wish everyone all the best for your exam. Thank you, children.